Well, there's a point to all this slope talk. The graph of f is shown below, and the derivative of f exists for all x in the interval from -7 to 4. Okay, let me just talk about what just happened. Not that much happened, but I snuck something in, and I just want to point it out. In the writing of this problem, I could not include equal signs if I was going to stop the graph there and there. Okay, so we were talking about continuity and differentiability, and if I'm going to talk about the slope on this curve, I can't talk about the slope here at the end because it just stops. All right, just saying. Okay, so for how many values of c from -7 to 4, we're dealing with x values, does, whoa, all of a sudden this thing just exploded. Okay, this is the alternative form of a derivative. So I am asking about the slope at a point. The slope at any point c. This is the average rate of change from -7 to 4, or from 4 to -7. So what we're looking at here is slope at a point. Let's use the purple pen. Dare I? Slope. At a point. There we go. And this is the slope. There it goes. Come on, purple pen. You got it. Slope on the interval from -4 to 7. Although the slopes do not exist at the endpoints, we can find the slopes between the points. I don't know what happened as I was writing it, but the pen just all of a sudden came alive again. Thank you, ink pen. Okay, here's what I'm going to do. I'm going to represent this by connecting these two. Connecting these 2 points. I'll use a green one. Use the green pen here. We're going to just connect them. There it is. So there's a slope between those 2 points. And if you want to get technical, you want to look at it, you would say that the slope is 1 over 4. So probably 1/4. So the question is, how many points on this curve in between -7 and 4, so now I'm kind of reading the question again, but rephrasing it, for how many values from -7 to 4 do we have a specific slope at a point? Let me rephrase that too. Would the tangent line, for how many x values would the tangent line have the same slope as the average rate of change? You could word it like that. I think I'm going to write that down just so we can internalize it a little bit. For how many x values, I'm just paraphrasing here, between -7 and 4, but not including, does the tangent line at that specific point have the same slope as the average rate of change? Okay, so I want to know at how many points would we have a tangent line that has the exact same slope. So here we go. I'm gonna just kind of draw some tangent lines with the ruler. Okay, not draw, but just sort of trace them. So we have an increasing function. There we go. We're swinging this around and get this pepper out of the way off camera. You can't see it, but there we go. It was in the way of my ruler. And oh, whoa, look at that. Look. About right there. I feel like this slope is the same as that slope. About right there. It doesn't have to be exact. So somewhere around in here, we have the same slope. So there's 1 point so far. There's 1. And then we'll keep driving this team of oxen. I don't know where that came from. It's just a old farming metaphor, I guess. There we go. We're following the slope of this line. I'm just kind of following. Notice it decreasing. Notice decreasing, and then it begins to level off down here. And as it does, there we go. Oh, look, you see it. The ruler and that green line are parallel to each other, so they have the same slope. So it's about down here somewhere. That was a poorly drawn line. And then we'll proceed. You can see where this is going. You probably know the answer at this point. So we'll bring this up, and we have positive slope, and we come to here, and then, oh, there it is again. There it is again. The answer is 3. I may not know the exact x values or c values, but the answer is 3.